Hi everyone. So I come from this data science or data intelligence world where there is a common belief that all models are wrong and only some are useful, right? This basically means that statistical models lack the complexity of reality. And what we have seen is one of the main reasons for this is the knowledge that is predominantly in human readable format. And you really need to convert that knowledge for the machine learning algorithms to be accurate. And that's exactly today my presentation is going to be focused on, and how did we convert the knowledge into a machine readable or machine consumable format, and then apply the machine learning algorithms to increase the accuracy of business classification for insurers. Okay. So just before a quick introduction about myself, I'm Kavitha Lokesh. I come with overall 25 years of experience in IT and 20 years predominantly has been with Cognizant that has shaped me and given me an enriching experience. And my experience has been throughout in data and intelligence product development, selling products, and also offering management, specifically in life sciences and insurance industry segment. And that's where today my topic is solving a particular business problem in insurance industry. I would also like to take a moment to acknowledge my lead data scientist, Subir Das. He couldn't join us today, but he's the man behind the entire coding of the algorithms while I'm just presenting what algorithms we use. But he's been the man. You can always reach out to him on LinkedIn and his email. I will share this presentation once I'm done. How have I structured today's conversation? I want to spend a few minutes to give you the problem statement so that you can understand why this problem is very important for insurance industry to be solved. And then I also want to take you guys through how we evolve the solution. So we didn't start off the day one with ontologies, right? So it took a part of 9 months for us to solve. So I'll walk you guys through that and finally present how we came out with the concept metrics and what was our overall model architecture that we put in place. And then, as Dan said, we will address any of your Q&A that you would have. So let's get started. So our focus on the problem statement itself was small commercial business. Why is some small commercial business important? Because today, if you look, I come from North America, I live in New Jersey, and our focus was North America market, and America runs on small businesses. What does that mean? It's a home for 30 million small businesses, which is almost contributing to 98% of the business. And today that contributes to 50% of the workforce. And why is this so important for an insurance company? It's very simple. It's because it's a lot of money in terms of premium. So today it is a $103 billion market as per a McKinsey report for small commercial business for PNC insurance. And if you see that this is being challenged because today it is highly fragmented, which means that even the top insurers has only 6% market share. But if you compare this with auto insurance, today, a top insurer has anywhere between 20 to 30% market share. So that actually led them to say, okay, I want to focus in this market. And then if you look at it, 11 million firms still don't have insurance. And 40% of business buyers shop every year because they are small. They always want to see if they can get some insurance at much cheaper price. So this was a huge volume business for insurers and they all wanted to invest. But at the same time, it was very, very price competitive. But if you look at it, were the insurers able to really tap this market? No, because the process today is so tedious. The intake process is so tedious, very manual. And you can see there are several players in this ecosystem. You have the small business owner who wants to buy insurance. There are insurance agents today still on the commercial side. Agency channel is the predominant channel. 80% of the business sells through agency channel and probably around 20% on direct to consumer sales. And then it goes to the underwriters. It gets into the system to the underwriters and then back and forth that happens. And typically this takes around 10 days. And obviously, if you look at it, there are several friction points that comes into play. Like small business owner says, why do I need to give so many questions that I need to answer and give you all the data. Will my premium go up? The agent's friction is they have to go and enter all of this data across multiple systems. Every company, insurance company, had their own portal, and they had their own list of information that they collected to identify how to classify the business and also provide the right product for that particular small business. So insurance agents used to think, why should I enter all of this across multiple systems? And underwriters always, they don't trust the data that comes in, and they spend huge amount of time in assessing the data, and typically we have seen that it basically ends up with 50% of the data to be corrected by the underwriters, and specifically the classification problem. So not only the process is tedious, there is also other operational challenge. One is having innovative insurance products. What do I mean by that? Today, if you take small businesses, every business is unique. A dry cleaning business is different from a parlor hair, or it is different from a restaurant, because the risk exposures are very, very unique. So understanding the different risk exposure and also standardizing this product across different industry segments as well as across insurers is a big complex. Some insurers would say that as part of the business owner's policy, I would also add cyber endorsement so that they can protect if a particular business was attacked through cyber. Or they could say that I would also give protection, additional protection for different other risk coverages. And this used to vary across different industry. But if you take, again, I would compare it with auto insurance, which is very, very standard, right? You know, standard set of coverages that you get for an auto policy. So coming out with an insurance product which is standardized, which is easy for you to understand, is still a big challenge. And we said, hey, is this a problem that we can solve? Definitely not, because we come from an IT company. So the second problem that they were having is business classification. Business classification, if you look at it, there are 3 different standards today that the insurance companies follow. One is your SIC code, which is the standard industrial classification. That's a 4-digit code that has been there for quite some time. And then comes the North American Industrial Classification System, which is NAICS, which is a 6-digit code. And ISO is very specific for insurance industry, which is given by Verisk company. So identifying, and beyond this, the insurers also had their own internal classifications where they used to differentiate the different businesses so that they can identify the risk and accordingly provide the right rates for the premium. And then if you look at it, there were limited number of classification codes, so there was overlaps of businesses. So identifying the right business classification was very important. And obviously the other operation underwriting efficiency that I talked about was also a big challenge that we had to solve. So we came out with, this is an MVP product that we built, where we said, hey, the way we can solve this problem is bringing in the third-party data from different sources. Today, there are several data sources that you can tap into, both open source data as well as third-party data providers. So we decided to bring a lot of this data as well as scrape data from the websites and build an intake app for the insurance agents so that they can just get all the data pre-filled, so they're not wasting their time in collecting the data, but more validating the data. And we also built an underwriting widget, which was basically to provide a one-stop shop for all the information of data coming from multiple sources to the underwriters, so that the underwriters need not spend going after multiple systems to validate that data. So our focus was on 2 different core problems that we wanted to solve, which was the pre-fill and business classification. Today, I'm going to focus on business classification because that's where we really use machine learning algorithms to solve and automate this business classification. So again, I want to look into why is business classification important. As I said, it is associated to the rates. So based on the business exposures, the rates are determined. So if you don't determine, if you overrate them and say that, hey, there's a lot of risk, then you might end losing the business because of overpricing, or you could also underprice, and tomorrow when a loss is claimed, then you end up paying from your pocket. So it was a very important problem that the insurers had to solve. And also, if you look at it, most of the time they were finding the classification error at the time of when, for example, at the time of the premium audit, generally they do it either immediately after the quote is provided or at the end of the year as part of the annual audit. And obviously that was a surprise to the policyholders, and the policyholders wanted to move away. And also, it is also, as you all know, small businesses evolve. When you start a small business, probably you start off with just a simple restaurant, but then slowly you become a caterer, you could add a mobile truck to your business. So your business evolves over a period of time, and it was also very important to reclassify the business and identify the right risk exposures. Just to give you all a little more view into the complexity of this classification, as I said, there are 6-digit code in NAICS. I've taken an example of accommodation and food services business that we were trying to classify for commercial insurance. So you saw that the 2-digit code represent the sector, 3-digit represent the subsector codes, and 4-digit basically gets into the industry group. So if you look at on the left-hand side, let me just change my pointer. So if you look at your 7223 referred to the special food services, which was either the food service contractors, caterers, or mobile food services. Or if you look at 7224 was pretty much focused on drinking places. So you had to identify a restaurant which is selling predominantly alcohol versus somebody which was giving a snack, which is, as you can see here, 722515 was predominantly a business which was just selling snack or non-alcoholic beverage bars, because the risk of fire is much higher in a restaurant which is selling alcohol when compared to a restaurant which is selling a snack or a simple beverage over there. So getting to the 6-digit is, as you can understand, you need to really get to that nitty-gritties of this classification. And today, if you look at it, where is this knowledge? And I talked about human readable format. Today, if you look at the NAICS manual, you can see how the description is being laid out for a full service restaurant. And you can see here clearly, they say that a full service restaurant is where you could be doing alcohol beverages, you could provide carry out services, or you could provide non-theatrical entertainment. But once you become completely alcoholic, then you cannot be classified under full service restaurant. Or if you only providing carry out services, then you cannot be classified under full service. There were a lot of such nitty-gritties that was embedded into this text, which when we found out today, we have our own BPO team where we have people sitting and manually doing this exercise. So how did we evolve our solution, right? And by the way, this problem was not something that Cognizant was trying to solve for insurers, but this is also a problem that Census was trying to solve, because they were using their annual survey data to identify the classification of each business and provide data around each of the classification industry. But they were also trying to use some of the social data, and their project was involved around using social data to determine just the 2-digit NAICS code. And you can see the matrix, how it looks over here. And they were able to get to an accuracy of 30%. And we also found that the data that we were buying from third party was still less than 50% accuracy. So our goal was not to be at less than 50%, but get to about greater than 80%. So that was a very clear goal. For our product to be successful, we had to get there. So how did we evolve this problem solution, right? So just to give you all, we started off with keywords, moved into key phrases, then got into concept metrics, and now we are trying to standardize it into ontology. The training data that we had was very simple. We had the business name, we had the business address, we got the NAICS code for the sample training data set from the third party. And as I said, that was 50% accurate. And then we also did the web scraping. of the data about that business, because you really wanted to know what services are they providing today. And that information can only come from the information that's available in the social. So we got a lot of social information, be it Facebook or be it Twitter, Yelp. We also scraped their website. So we also got the URL from the third party, and then we scraped that data from their URL. And we had it for 10,000 businesses across for all these 722 class codes. So we started with a rule-based approach. So we had our team, which was basically going and doing it manually. So we went and asked them, how are you doing this? How are you classifying the business? They had, for every class code, they had a set of keywords that they had identified. They took those keywords and they were going and searching across multiple sites about the business. And then they were actually classifying the business into the respective class code. We said, oh, wow, this is a very simple process. Why don't we use a rule-based approach? So we took the keywords from that team, and then we did a simple expression search on the text that was coming in. We figured out that's not going to help us because the keywords were not extensive and they were overlapping keywords. Then we said, okay, how do we do it? Then this basically led us to machine learning approach. And we said, okay, let's try out simple machine learning approach where we use the text, we tokenize that to identify the word frequency, and then we use simple machine learning algorithms like logistic regression, XGBoost. And we found out very quickly that our training data set was completely lacking the signals, and it was not able to identify. Our accuracy was somewhere between 10% to 40%. And then this led us to a question is, how do we really improve our training data set? Is the training data set sufficient for us to build a model? And that's where we started digging deeper into the training data, and we figured out the class code representation of the data itself was very less. And as usual, you know, every data scientist, when they come to you, they will ask us, give us more data, give us more data. And they were asking us to give data for every class code, at least minimum 2,000 businesses information. And I said, this is not a way for us to approach. I cannot get several businesses information as a training data for you guys to solve this classification problem. So then what we said is, okay, what can we do further? So we then started to do manual extraction. We also did some signal leaking. We took the NAICS description and then we embedded into that web scraped information to see if that is helping. But that gave us around 10% boost, but really not getting to where we wanted. And if you looked at it, we further built key phrases, and then we tried to bring in additional keywords, and we started digging deeper into that description and converting into that keywords. And that's when we figured out we were able to get to 20% more accuracy. So overall, we were at 60%. So this clearly told us the more we can convert the knowledge that is there in that NAICS description into a machine readable format, we can get to our accuracy of greater than 80%. And that's when this concept matrix itself was born. So what we did was, for every class code, if I show you the Excel sheet where we put all together, you would see the complexity of this. We were able to identify the concept categories. Like, for example, we found out for a restaurant, there are different concept categories. It depends on the service style. It depends on service payment, location type, what food are they serving. So there were several such concepts, and we tried to identify all the key concepts for that particular industry segment. And this again, you could relate it to keywords, right? But then what we really started to build out is that multidimensional concept matrix. What we said was, hey, are these concepts mandated for each of the 6-digit NAICS code? Like, for example, here you can see 722310. It is very important if you have to classify any of the restaurant business under 722, you cannot be in a dinner cruise. So that was a very clear no. If you are on a dinner cruise, you are a restaurant on a dinner cruise, you have to get classified in a different segment. So it was a mandated, there should not be any association to dinner cruise. Then we also figured out if you are a food service contractors, it is not something that you pay immediately, but you pay over a contract. And then you also have to be an organization-based food contractor where you're doing a contract for a duration of certain period. Versus if you look at caterers, it was not that required. Caterers, you could get paid immediately on a contract basis still, but you don't need to be a food contractor to be a caterer. But you could do an off-premise or an on-premise even. So, and if you look at drinking places, the complexity was building this odd situation, right? If you are a drinking place, you could either be a drinking place, which is a bar, or it could be a tavern, or it could be a nightclub. So and then there were other mandated that you cannot be, which is no's, right? Which is basically you cannot be on a dinner cruise. So we really build this multi-dimensional concept matrix. And then we figured out by attaching this concept matrix to our training data set, we were able to really boost, and we went to an accuracy of greater than 90%. But as you can see, this concept matrix can evolve because every concept can be something that you can come out with new. So modeling this in a table column structure was not possible. So we started to build out the ontologies. This is just a sample screenshot where we said that every concept has a relationship to a particular class code, and it could be a mandated relationship or it can be an optional relationship. And even in the mandated, it can be a mandated no or a mandated yes. So we started building all of this relationship into an ontology so that this file, or basically this triples RDF, is available for us to attach to any models and then further improve. And in fact, we evolved our concepts itself. We slowly started including not only keywords, then we also started including associated keywords. So if you call a bar, somebody could call it something different. So we figured out all the associated keywords that was given in the NAICS. We started compiling that. And then we also started doing the relationship between the class codes. So this entire knowledge we started converting into an ontology. And that really helped us to solve this problem. So finally, if I have to present you, how was our model architected to solve this business classification? So I'll just take a few minutes to walk you guys through this, right? So you can see your M's. M's are basically the models. And you can see the data. D's are basically where we were preparing our data set. And E's are where we got the entry. So if I walk you on the top, we started with, as I said, the entry was very simple. It was a business name, address, URL, and the information, the description about the company itself that we got from the third-party data set. So what we did was we put a gateway model, which basically first helped us to determine the 3-digit NAICS code. We figured out using the TF-IDF matrix as well as SVM, we were able to narrow it down very quickly to the 3-digit code. And then the concept matrix that you see here, which we were building it as through our ontologies and then serializing it into a structure, as you saw on that Excel sheet. We built that and then we attached that to the, as you can see here, the data preparation, which was the raw data set. So we took the golden data of that, the training data of those 10,000 records. In fact, we reduced the number of records, training data record set, because we were able to build this concept metric. So we did it for our golden data records was only 300 data records that we used here. And we applied this concept matrix and we prepared that. That fed into our predictor model. And as you can see here, the concept matrix was fed to a naive-based algorithm, and we built logistic regression models. And you can see here, this M2 has 1 to 8. This was basically, we built a logistic regression model for every class code. And as you saw in restaurant, we had 8 class codes, and we built one for each of the class codes. And if you see the bottom, this M3 layer of the model was basically to convert, because in real time now, while you train the data set and you are able to give the concept metrics, the incoming businesses, you had to build a similar concept metrics. So we built an M3 model, which basically took the data and used the GLOW embedding approach to create that concept metric for the incoming business. And that fed into the predictor model, and we were able to get our accuracy to about 90%. So if I have to conclude, just some data points to see here. So you can see this was the concept metrics that we created out of the model 3 for the incoming business. So we were able to identify for each of the concept, which concept was taking the highest priority and what was the percentage of it. And this one is the output from our predictor model. In fact, you can see that for full service restaurant, we were still between 78 to 78%, and then we further refined our concepts and we were able to increase this also to about 90%. And the bottom two graphs is basically to show you the distribution of the data across different class codes that we had. So in summary, if I have to conclude this conversation, our 9 months journey, basically we were able to achieve 90% accuracy, and we standardized this approach, where we said that we will first convert our unstructured data into a business ontology. So all the next description, we are not there yet. We have done it for construction business. We have done it for contractor business. We have done it for restaurant business. But we are trying to convert all for the entire next code over a period of next year in terms of converting that into a business ontology. And then we are trying to serialize that ontology into a concept matrix. It could be a JSON format. It could be a simple tabular format that you guys saw. And then attaching that concept matrix to the training data set for each of the industry segment. And then create models for converting the incoming data to produce that concept matrix and finally predict the classification with high accuracy. So I just want to conclude. I know I talked so many topics. Hope at least I was able to share some of the information that we took 9 months. Hope this helps you guys if you are embarking on business classification and if a lot of your context is in a human readable format, you are able to take this approach and convert it into an ontology and apply that as a concept matrix to your algorithm and boost your accuracy. In fact, my data scientist was saying, at least we took 9 months and we figured out our data is in human readable format and we were able to convert it into a machine consumable. But Elon Musk took 5 years to figure out that entire infrastructure, the road infrastructure, is only human consumable and it cannot be done for automating the cars, right? So I'm hoping there's much more larger problems to solve. I think this was a simple problem. I would say if we look back, it looks very simple now, but I'm happy that we were able to solve this problem and we are able to take this approach across all the other class codes also. With that, I would like to end and see if there are any questions. Dan?
Oh, thanks a lot for the talk. Yeah, I would also say the problem always seems simpler once you've done it and then you're looking back. But yeah, it was quite a journey. And yeah, also on this line, I think I've always dreamt of having a pub someday. So it's good to see how drinking places can be classified.
Yeah, I mean, and if you get into it, gets even more interesting when you get into multiple classes. In fact, if I share my Excel sheet for construction business, it gets even more nastier because the construction business has public construction, residential construction, and there are different contractors in construction. And how do you really classify them? Somebody would be doing wood framing, somebody would be doing roof construction, somebody would be doing your different like slabs, your basement. So you really need to identify different class of codes because the risks are completely different. So we were even able to appreciate the challenge that the industry is facing today, right? And I think that's where, from intelligence side, we were trying to see, can we solve this problem for them?
And because we're not doing technology for the sake of technology. It's always to solve some real problem. Vlad, how about you? What are your thoughts?
Yeah, I was wondering, I noticed you're using accuracy as a metric, but at the same time, you also computed other metrics. I was wondering how you settled on using accuracy for this to measure performance.
I think in terms of measuring the performance, I would defer it to my data scientist, because he was the one who really coded this algorithm. So he did multiple, as far as I know, he did multiple approaches, but then he figured out the way he was scoring this, which was the simple score that he applied in terms of doing from each of the logistic regression. He had classified the percentage, which one was taking the highest priority, and which was, so he brought out a percentage for each of the class codes and each of the concept basically. And using that, he applied another algorithm to see which scored higher, because you have to pick, you cannot give all the 100 class codes that a particular business would be doing, right? So then based on that percentage, he was able to really bring out which one is the primary and which are a couple of secondary class codes. So I don't know if I answered that fully, but I would again give it to my, if you want, I can bring it offline, the conversation in terms of what really exact algorithm that he used to classify, to identify the accuracy.
Not necessarily, but I think it also depends on the domain and on the specific business case that you were handling. So, of course, in that regard,
yeah,
this is pretty good information. I was also wondering, I noticed that you had a significant performance increase when you started adding some more features, when you started enriching the data set. You couldn't add more rows, but you didn't have more data. But then you started to extract more and more information from what little you had. And I wanted to ask, if you were to start this project all over again, would you change something in that approach? Perhaps start with, examining the data earlier on, or some reprioritization?
In fact, when I started this project, we started with ontology. We put our team through a training. We created the ontology model. We had an ontology expert, and he created all of this relationship for a couple of class codes. But when we gave it to the data scientists, they figured out they were not able to figure out how to use that information. And then we had to break it into a structure. In fact, I can share you my screen where I will show you literally how we had to break the structure for them. Can you see my screen?
Just a second. Not yet. Yeah, now it's showing up and we're putting it live. Yes, we do.
So here, if you can see, we had to literally convert this into various class. And you can see as we went with different class codes, it became even more complex. And that's where we brought in associated concepts and keywords. We brought in the cross-reference NAICS code. And also we were not only solving for NAICS, we were also trying to solve it for ISO and SIC. So there were concepts which are very, very specific for ISO and SIC. So we started building this into this format where we call this as a concept master. And then we started to build this matrix for them. And only when we gave this matrix to the data scientists, because they wanted to have everything in zeros and ones, right? That's how they recognize the data. And only when we gave this, they were really able to appreciate how this concept matrix can really help them to solve the problem. So I would say, probably now if I go back to my data scientist and say ontology, you will appreciate it. But if somebody is starting from scratch, ontology would be very difficult, because modeling the ontology is also very difficult, because you really need to understand the relationship and how you want to model that relationship. So I would say start with a simple Excel sheet, apply your concepts and do the mapping so that you can really understand how this is all coming together, and then get to the maturity of getting to ontologies. So I would not change the approach. I would not start with ontologies, especially if you're starting with a newer domain.
Yeah, I so agree with you. I think oftentimes we're so eager to get something done that we're going headfirst to let's do modeling, let's create something, let's put it live, and instead of just looking at the data and trying to see what's in there, what makes sense, what doesn't make sense. So yeah, thanks for this advice.
And in fact, you can see here, this is how they converted it, right? So all the S and No's that we gave, they attached it to the training data set. As you can see, we had different data set. So they attached it to each of this class code that they had, which was a golden records that we created manually. So they were able to attach that concept matrix to this, and they converted it into zeros and ones. And then they were able to apply the other algorithms to get to that accuracy. Yeah.
Yeah, very cool. Very cool. Thank you. I no other questions from me. Thanks so much. Not sure if Dan has.
Yeah, I was going to say it as well. Zeros and ones. Now it makes sense.